Example 4 for 9.3 in Math 30-1 here is a pretty typical, I would say, application of a rational equation, which is an average, or in this case, a shot percentage, which is the average number of successes. So it says that Larry has attempted 19 free throws and been successful on 12 of them. And then if he's successful on every attempt from now on, however he figured that out, how many more free throws does he need to attempt before? And maybe it should say how many more free throws does he need to make, because he's making all of them. He's not attempting them. But anyway, his free throw percentage needs to be 80. Now, I'm going to put over here that, right away, I'm going to change this into 0.80. And then what we can say is that our percentage as a decimal is equal to the, successes, try to make sure I spell that right, successes, I think I did, over attempted. Again, not an English teacher, so hopefully that's spelt right. And I hope that makes sense, right? I mean, if he's made 12 out of 19, then 12 divided by 19 will give us his percentage as a decimal. If you want it as a percent, you'd have to multiply that fraction on the right by 100. But, really, I always like writing this for students, that percent literally means per 100, which is to say that 80% is 80 divided by 100. Which is 0.80. I think that's a misconception among some people, that percentage and decimals aren't connected. It's just become the kind of colloquial way we talk about, successes, or, the amount you got right on a test or something like that. Okay, back to this, sorry. So right now, and I'm just gonna put percent, maybe I'll put P, Larry's gonna make more free throws. So I'm gonna make X equal to the number, should have put a hashtag there, the number of additional free throws. So the percentage of shots as a decimal that he makes as a function of X is going to be, well, right off the bat, he has made 12 free throws out of the total 19 that is attempted. And that's what percent he has currently. But he's going to keep making free throws. And again, he's somehow figured out that, he can make every single free throw from now on, which is fine. That's an assumption for this question. Now, what that means is that he's going to continue to shoot. So his attempts are going to go up. So we're going to add X to the denominator. But because he's successful on every single free throw from now on, I'm also going to add X in the numerator. Now, that's really important, that when we look at that equation, it makes sense if he's making every single free throw from now on. Sooner or later, you might get a question where it says, okay, Larry makes half of the free throws from here on out. Then we would write that as 12 plus 0.5X over 19 plus X. And that's there to indicate that he's making X, further attempts, but he's only successful on half of his future attempts. That's not the question. I just wanted to make sure I threw that in the notes, because you're likely to run into a question like that, because I don't know what Larry has done, but it's pretty unlikely that he's just going to magically start making every free throw when he's sitting at, right around 2/3. All right, now the question wants us to know, when will P of X be equal to 0.80? And that's really important, that creates the equation for us, because what we're trying to solve is, when is 0.80 equal to 12 plus X over 19 plus X? Now, before we go any more, and we're going to solve this algebraically in a second, I think it is important to remember what X is. X is the number of additional free throws that Larry makes. Well, Larry could not make any more free throws. So that means that X could be 0, but more importantly, it means that X has to be greater than 0. Larry can't make negative free throws. And I just want to put one other piece of information in here, that X has to be an element, and I'm going to put integer number system there. I don't play a lot of basketball, but I do not believe you can make 0.2 free throws. Right? So X is going to go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. We're never going to have any decimals or fractions in there. Now, I like writing this stuff down, because it's important to remember that although this equation may have a decimal answer, we might have to round that answer up to make sure that it fits with the context of the problem. All right, to solve this guy, much like example 1 and 3, I'm going to make it non-rational. And the way that I do that is I multiply by the lowest common denominator, but there's only one denominator. So that makes it a little bit easier. On the right-hand side, I get something a little bit ugly. I get I'll keep that 0 there one more time, 0.80 times 19 plus X. The right-hand side, though, is now just 12 plus X, because the 19 plus X cancels with the denominator, 19 plus X. All right, from here, maybe I should have kept this as a percentage, but we're going to roll with it now. I'm going to distribute that 0.80 into both terms. So 0.8 times 19, I get 15.2 plus 0.8x is equal to 12 plus x. Now, this is not quadratic, right? The highest degree on x is 1, so it's a linear equation. You have probably been taught for linear equations to get one side with all the variables, the other sides with all the constants, and then make sure the coefficient on the variable is 1. That's the best technique by far. I really do like pointing out that you could also get one side equal to 0 and solve this via factoring. But for the most part, students would rather do it with the variable on one side, the constants with the other, and I'm going to do it that way. So I'm going to subtract the 12 from both sides to move my constant, and I'm going to subtract the 0.8x from both sides. Not the only way of doing this, but I like when my x is positive. 15.2 minus 12 is 3.2. X, which is to say 1x, minus 0.8x is 0.2x. The last step is to completely isolate my variable, and what I get is that 16 is equal to x. And that's our solution. So I'm just going to put that Larry must make 16 additional, and just because I find this part of the question a little bit annoying, I'm going to put 16 additional successful free throws. Now, I always like checking if it's right. So if this is correct, then we should be able to say that the percent that he has gotten right as a decimal, if he makes 16 additional free throws, is, and I'm going to put greater than or equal to 0.8. Now, I don't want to put greater than. Sorry, I shouldn't have done that. We are going to say that it's equal to 0.8. If we've done this correctly, then it should be good to go. Now, if we evaluate this at 16, that's going to be 12 plus 16 over 19 plus 16, which is to say 28 over 35. And if you put 28 divided by 35 into your calculator, guess what you get? You get 0.80. Now, I like these questions a little bit more as inequalities. Maybe it says, Larry wants to be at least 80% successful. Well, then he needs to make at least 16 more successful free throws. If he makes, an additional 20, he's going to be above 80%, and he's probably going to be just as happy about that. Okay, that's 9.3, which is solving rationals. I am going to put the full assignment up here, but make sure you're checking Google Classroom for any modifications. Keep chipping away at this. Chapter 9 is one of those chapters where usually students like 9.3. It's a little more concrete, a little more systematic and step-by-step, but we have to make sure we're comfortable with the graphs and how to transform and manipulate them as well.